Hey guys, this is Miss Adams. Today we're going to be looking at the 6B review. So this is going back to our test review from Unit 6B. This is a little bit of a refresher for you, just in case you want to retake that test or in case you're just trying to review the material to get prepared for the next year. So let's go ahead and jump into it. The first thing we're going to look at is simplifying square roots or simplifying radicals. So it says all work must be shown using either the perfect square root method or the perfect square method or the factor tree method. I'm going to go with the perfect square method because I feel like this is a little bit easier. So just a refresher, we've got to remember what our perfect squares are. If we're going through them, 1 times 1 is 1. I'll just make a list at the top. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. And 12 times 12 is 144. We could keep going. Glorious thing is that we have a calculator so we can actually find some of these perfect squares if we don't really know them. But this wants us to show our work when we're simplifying these radicals. Let's look at the first example. It says 2 times the square root of 100. Looking at our list up here, we have 100 here. That was 10 times 10. So 100 is a perfect square. So we can say that the square root of 100 is 10. So this simplifies to 2 times 10, and 2 times 10 simplifies to 20. So 2 times the square root of 100 can now be simplified to 20. Let's go on to problem 2. It says the square root of 24. Looking at our list, we know it's going to be some number in between 4 and 5 is going to be the square root of 24, but it's not perfect because 24 is not a perfect square. So let's look at some of the factors of 24. 1 times 24, that doesn't really help us much because anything times 1 is itself. 2 times 12 is 24, but 12 is not a perfect square, so that doesn't really help us. Then we have 3 times 8, so we're getting closer, but 8 is not a perfect square either. But we also have 4 times 6. 4 is a perfect square. The square root of 4 is 2. So let's rewrite this as the square root of 4 times 6. So we can write that as the square root of 4 times the square root of 6. And we know that the square root of 4 simplifies to 2, and we're going to leave 6 in the radical. So the square root of 24 simplifies to 2 times the square root of 6. Now, yes, you can go ahead and just plug that in your calculator, and if you have a nice little TI-30XS, if I plug in the square root of 24, so I say second x squared and 24, if it's in math print, it's going to tell you 2 times the square root of 6, which is nice, but that's not, we want you to show your work. All right, let's go on to problem 3. Now we're dealing with addition when we're looking at simplifying radicals. In order to do addition or subtraction, the radicals have to be the same, so they have to have a common radical in between them. Looking at this, we have 4 square root of 3 plus 5 square root of 3. Those both have the same radical, the square root of 3. So we can simply add the terms on the outside, so adding the coefficients, the whole numbers on the outside. So I'm going to say 4 plus 5 multiplied by the square root of 3. Since both of those things are multiplied by the square root of 3, 4 and 5, we can factor them together, put the 4 and 5 together, and still multiplied by the square root of 3. So 4 plus 5, that simplifies to 9 times the square root of 3. Now let's look at number 4. So we're doing subtraction, so we want them to have the same radical once again. But looking at number 4, they do not have the same radical. We've got 3 times the square root of 8 minus 2 times the square root of 18. Let's see if we can simplify these a little bit to where they would have the same radical. Well, looking at the square root of 8, that's not a perfect square, but I bet there's a perfect square factor for 8. We do 1 times 8, we don't need it. 2 times 4, though. 4 is a perfect square. So let's rewrite this as 3 times the square root of 4 times the square root of 2. I'm just going to put my perfect square factor in the first radical so that we can reduce that. All right. Well, 3 and the square root of 4, I know that's a perfect square, so it's going to simplify to 2. So this is now going to become 3 times 2 times the square root of 2. 3 times 2 is 6. So that's 6 square root of 2. And then let's go over to this 2 square root of 18. Remember, we're still subtracting through all of this. And I'll do this in like a purple color. So we're looking at 2 square root of 18. 18 is not a perfect square, but it does have a perfect square factor. 2 times the square, or 2 times 9 gives us 18, and the square root of 9 is 3. So I can rewrite this as 2 times the square root of 9 times the square root of 2. We know the square root of 9 is 3. So we're going to say 2 times 3 times the square root of 2. And 2 times 3 is also 6. And this is times square root of 2. So let's look at that. We've got 6 square root of 2 minus 6 square root of 2. They both have that same radical, square root of 2. So we can rewrite this as 6 minus 6 times the square root of 2. Well, 6 minus 6 is 0, and anything multiplied by 0 is 0. So the simplified version of 3 square root of 8 minus 2 square root of 18 is just 0. All right, let's go on to problem 5. Now we're dealing with multiplication with radicals. When we're multiplying radicals, we're going to multiply your outside terms by themselves and the inside terms by themselves. So we're grouping, okay? So looking at this, I've got 2 radicals. I've got 8 and 2 under my as my radicands, underneath my radical symbols. So I'm going to do, just combine them underneath the same radical here. I've got 8 times 2. Well, 8 times 2, that's 16. So now I've got the square root of 16. 16 is a perfect square. The square root of 16, well, I know 4 times 4 is 16. So therefore, the square root of 8 times the square root of 2 is going to simplify to 4 as your final answer there. Now let's look at number 6. So for number 6, we're going to multiply the outside terms and then multiply the inside terms. So we're going to do negative 2 times 5. And then we're going to multiply that by 4 times 16. And that part is underneath your radical. But looking at that, could I have simplified this? Absolutely. So we had the square root of 4, that simplifies to 2. And we had the square root of 16, well, that simplifies to 4. So we'll go back and double check to make sure that we get the same answers both ways. But let's look at it this way first. So I've got negative 2 times 5, that's going to give me a negative 10. And then square root of 4 times 16, 4 times 16, well, that's going to give me 64. So I'm going to have this negative 10 multiplied by the square root of 64. 64 is a perfect square. 8 times 8 is 64. So this now reduces to negative 10 times 8, which is just going to give me negative 80. But we could have looked at this originally, and instead of having a square root of 4 here, I could have replaced that with a 2, which would have been negative 2 times 2. That's going to give you a negative 4 in the first parentheses. And I could have looked at this here. Square root of 16 is 4. 5 times 4 is 20. So I would have had 20 as my second parentheses, and negative 4 times 20 is also this negative 80. Both ways work.